We're going to review parallel and perpendicular lines. Now there are specific things about the slopes of these types of lines that we need to know to understand the full algebra concept. So the first type of line we're going to talk about is our parallel lines. An example of parallel lines are the lines like on this paper. Okay, they are going the exact same direction. They are parallel. Now what's specifically important about these is that they have the same slope. These two lines will have the same slope since they're going the same direction. Okay, an example one, of two lines that have the same slope are the following equations. This is y equals 2x plus 5 and y equals 2x minus 15. Now if you notice that both of these lines have a slope of 2, because that's my m in y equals mx plus b, so we would be able to say that they are parallel lines. Second example, they're not going to be written in y equals mx plus b form immediately. We're going to have to do that ourselves. So they're given to us in this form. We say negative x plus 3y equal to negative 5 and negative 2x plus 6y equal to 30. These are not written in y equals mx plus b form, so we have to get them there. In both equations, we would move the x's across the equal sign and they become positive, so that first step will be over here. We'd have 3y equal to x minus 5 and 6y equal to 2x plus 30. Now to solve for y, we would divide by the two numbers in front of the y. So the first equation would turn into y equal to 1/3 x minus 5/3. The second equation would turn into y equals to 6x plus 5. Now you'd say, oh, well, those aren't the same slope. Well, actually they are. You have to reduce the fraction. If you notice, this fraction will actually reduce to 1/3 as well. So because the slopes of the two lines are the same here and here, we would say that these two lines are parallel. The second type of line we can have is what's called a perpendicular line. Perpendicular. Now these perpendicular lines, they meet at a right angle. So if you have one that comes in like this, your other one will be going exactly the opposite direction and they meet at a right angle. This is more important in geometry to know that they meet at a right angle. In algebra, we have to know that these parallel lines, or perpendicular lines, have what are called opposite reciprocal slopes. Opposite reciprocal slopes. Okay, this is the flip and flip. Meaning we're going to flip both the sign and the fraction. Our first example of perpendicular lines is the lines y equal 2/3 x plus 5 and y equals negative 3/2 x minus 7. If you notice that their slopes here are 2/3 and negative 3/2. So we have flipped the fraction and went from 2/3 to 3/2. See how they're flipped? And the sign has changed. Opposite, that's the sign. Reciprocals, that's the flip. So those two lines, because we notice how their slopes are related, would be called perpendicular. Let's try a second example. This time again, they're not going to be written in y equals mx plus b form for us. We'll have to do that job. We have negative 5 plus y equal to 2x and x plus 2y equal to negative 16. Now there are a few things that need to move across the equal sign before we can divide. So we move that 5, we'd have y equal to 2x plus 5. We need to move the x in this one. This would be 2y equal to negative x minus 16. First one, we don't have to divide by anything. The coefficient is 1. So if we divided by 1, nothing would change, so we're just going to leave it. The second one, we need to divide by a 2. So if we divide by 2 in each term, we'd have negative 1/2 x minus 8. This time my slopes are 2 and negative 1/2. Now we can tell that these are opposite because obviously this one's positive and this one's negative, but why are these reciprocals? Well, we need to remember that 2 can actually be written as 2 over 1. So we are still flipping the fraction. The last type of option you can have today is what's called neither. Okay, these neither are when the slopes are neither the same nor their opposite reciprocals. Pretty simple. So if it's not parallel or perpendicular, your only other option is either. Okay, we're going to do one type of a question that you may see on the STAAR test. Type of questions you may see look like this. They may say, write an equation that is parallel to y equals 4x plus 5 that goes through the point 1, 1. Okay, that's what the question tells you. To write an equation of a line, you need a point and a slope because we have what's called point-slope form. We've talked about this. This is y minus y1 equal to m times x minus x1. This equation is found on your formula chart. You just have to remember how to use it. This is the slope, and these two are the points that we're given. So all we need to do is make sure we have a slope. But if we know that these are parallel, that means that they should have what kind of slope? If you said same slope, you're right. They should have the same slope. So we look at the original equation, we say, okay, it has a slope of 4. So I know what the slope of my equation should be. We should fill this in with the same point, my slope from the first one, continuing at that same point. Check your answer choices. It may look like that, and we'd be good to go. We have written an equation. If they don't, you may have to write it in slope-intercept form, which means we simply distribute. Again, we reviewed this before. Add 1 to both sides. There you go. So we have two options, either here or here, for our writing an equation. If it said the same question, but instead of parallel, came over here and we said perpendicular, the only thing that we would change about what we did here is that instead of filling in 4 for my equation, I would fill in the opposite reciprocal. Be x minus 1 equal to no longer 4, but the opposite and reciprocal slope. Okay, so this is for perpendicular. We have to remember that that means that they are opposite reciprocal slopes.